This is question number 7 from Pure Mathematics 4 of January 2021. So the question says the figure 2 shows a sketch of a part of a curve with equation y is equal to e to the power of 2x sine x. So what we need to do here, we need to integrate e to the power of 2x sine x with respect to x. For this question, we will be using a method which is known as integration by parts. For integration by parts, we use a formula which is v u minus integral of v du dx with respect to x. Now, what is v u du dx? We'll see that. Let's write the question. The question is integrate e to the power of 2x sine x with respect to x. Now I have two components in my question. One is e to the power of 2x and the other is sine x. I have to name one of them as u and the other one as dv dx. Now which one will I choose to be u and which one will I choose to be dv dx? So for example, I choose u to be e to the power of 2x. Now, if I choose u to be e to the power of 2x, it's easy for me to find du dx. Let's see. So if u is e to the power of 2x, then my du dx, so differential of e to the power of 2x will be e to the power of 2x, and then we have to multiply this by the differential of what is inside the function, which is 2x. So the differential of 2x is 2. So differential of e to the power of 2x is 2e to the power of 2x. On the other hand, I have dv dx, and that will automatically be the other component that I have, which is sine x. So let me write here sine x. So if dv dx is my sine x, I should be able to easily integrate this to find v. And I know that the integral of sine x is minus cosine x. So now that I have managed to find my du dx and my v, I can plug in these into the formula for integration by parts. So first I will multiply u and v together. So u multiplied by v, and then minus the integral of v into du dx. So we just need to substitute values into this formula, which is formula for integration by parts. So let's substitute vu. So that is equal to v is minus cosine x, u is e to the power of 2x, and that minus sine, next integral of v, which is minus cosine x, into du dx, which is 2e to the power of 2x, and then with respect to x. So into 2e to the power of 2x with respect to x. So in the next step, what I can do is I can write the minus and the 2 together. So I have here, this is equal to minus, I can write this as minus e to the power of 2x cosine x minus 2, the minus and the 2 are written together. Then I have cosine x and e to the power of 2x with respect to x. Now since the minus 2 is a constant, I can pull it outside the integral sign, and the minus along with this minus will become plus. So this is equal to minus e to the power of 2x cosine x plus 2 into the integral of cosine x e to the power of 2x with respect to x. Now once again I have come to a point where I need to complete this question, I need to again integrate, and again this integration will be by the same method, which is integration by parts. So once again I have to choose u and dv dx. So again, when I choose u should be differentiate, I should be able to differentiate u easily, and the other component that I choose as dv dx, I should be able to easily integrate it. So once again, I choose my u to be e to the power of 2x. So u is e to the power of 2x, and I can conveniently find du dx, that is differential of e to the power of 2x will be e to the power of 2x, and what is inside the function 2x, differential of that will be 2. Differential of 2x is 2. The other component will be my dv dx. So cosine x is my dv dx. So I'm going to write here dv dx, that is equal to cosine x, and the integral of cosine x, which is v, is equal to minus sine x. Sine x. So once again I have all the values that I need to substitute into this formula in order to find the integral. So I'm going to integrate this with respect to x. So first I will copy the first few steps as it is. So this is equal to minus e to the power of 2x cosine x plus 2. So I'm going to make a bracket because 2 will be multiplied by whatever is ahead. So I have, according to my formula, uv or vu, so u into v, so that is e to the power of 2x minus cosine x. So e to the power of 2x into minus cosine x. Oh, I'm sorry. It's this one, u and v, because we are integrating for this one here. So my u is e to the power of 2x and my v is sine x. So into sine x. And then minus the integral of the v into du dx. So v is sine x into du dx. I'll just make some room here. Sine x into du dx, which is 2e to the power of 2x. 2e to the power of 2x, and with respect to x, bracket close here. So now again I have some simplification steps here. So I have 2 here, which I will pull out outside the integral sign because it's a constant. So I have minus e to the power of 2x cosine x plus 2 into e to the power of 2x sine x minus 2 integral of sine x and e to the power of 2x with respect to x. So I've just removed the 2 out, and now I have removed this 2, sorry, I have removed this 2 outside the integral sign, and I've written here it multiplied with the minus and became minus 2. Now in the next step I need to multiply 2 with the 2 terms inside the bracket. So 2 into this and 2 into this term. So let me do that. So I have minus e to the power of 2x cosine x plus 2e to the power of 2x sine x, and then 2 into negative 2 is minus 4 into integral of sine x e to the power of 2x with respect to x. So I've opened the bracket, and again, if I observe here, again I have come back to, in this part of the question, I have returned to what was there to integrate in the original question here. So the process is like going on. It will keep on continuing like this. So how do we work it out? Because after so many steps of working, we have got a part again which is the same as the question to integrate, which means the process will keep on going on. So after this step, we should realize that all of this is equal to the question which is written here. So now in this step, what I'm going to do, I'm going to copy the question, which is integral of e to the power of 2x sine x with respect to x, that is equal to minus e to the power of 2x cosine x plus 2 e to the power of 2x sine x minus 4 into integral of sine x e to the power of 2x with respect to x. At this step, I realize that on either side of the equation, I have got like terms. So integral of e to the power of 2x sine x and minus 4 into integral of sine x e to the power of 2x. They both are like terms, so they can be pulled to one side of the equation and simplified. So what I will do here is I'm going to pull out. So the first left side, I'm going to write it as it is, which is e to the power of 2x sine x with respect to x, and the plus 4 into integral of, now I'm going to write it in the same way, e to the power of 2x sine x. So it's the same thing here, e to the power of 2x and sine x. So I've just written it the other way around. They are products, so it doesn't matter if we change their position. And then with respect to dx, and that is equal to what is left on the right side, because I pulled this on the left side. So what is this is left on the right side now. That is equal to minus e to the power of 2x cosine x plus 2 e to the power of 2x sine x. So now we can add up these two like terms. E to the power of 2x sine x is like 1 e to the power of 2x sine x plus 4 into integral of. So we have 1 into integral of plus 4 into. So we have total 5 into integral of e to the power of 2x sine x with respect to x, and that is equal to minus e to the power of 2x cosine x plus 2 into e to the power of 2x sine x. So since we need to find the value of integral of e to the power of 2x sine x with respect to x, we can make that the subject of formula. Move the 5 is getting multiplied on one side, so it will divide onto the other side. So we have integral of e to the power of 2x sine x with respect to x is equal to minus e to the power of 2x cosine x plus 2 into e to the power of 2x sine x all divided by 5. And that answers my question. So in this question, we used integration by parts twice. And in spite of using integration by parts twice, we still had a part which could be integrated again. which was a replica of what our question was, which is this part. So we have to be careful. In this part, we need to realize that this is the same as what is the left hand side of our equation, and pull the two like terms together in order to simplify them. So once we pull out the two like terms together, we can make the term that we require to find the subjective formula and find its value.